Today's video is on lessons 4.3 and 4.4. Today we will begin discussing exponential functions. You need to know that this is the general form of an equation of an exponential function. Just like in the equation of a line, you will recall in a line it was y equals mx plus b. That was one of the forms. And you needed to know two things. You needed the slope and the y-intercept. Well, it is very similar with exponential functions. You need to know two things. You need to know a, and make a note to yourself, a is the initial value. Basically, it is the y when x is 0. So whatever the y value is when your x value is 0, that is your a. Your b is your constant or your multiplier. It is the number that you would multiply one y value by to get the next. And it will be constant. So let's say the multiplier was 3. That would mean you would multiply the previous y value by 3 to get the next y value. So we're going to do two examples. We're going to consider two different equations. They are both exponential functions. By the way, if there is no a value, then it's 1. So if there is no number out in front, the number that's right next to the exponent is always your b. So this is your b for this particular example. Since there is no number out in front of the b, it's 1. So you could rewrite this as 1 times 2 to the x. And usually if there are two different numbers, you put the b in parentheses to kind of separate it from the a. Now you could use your calculator, but I'm going to show you how to do this by hand because it is good practice with what to do with exponents, especially negative exponents. So for the first table, we are looking at the function y equals 2 to the x. So any x that you plug in is going to go in the exponent spot. So to get the first y value when x is -3, this means we're doing 2 to the -3. If you recall from last video, you learned that when you have a negative exponent, you move him to the other side of the fraction. Remember, every number can be written as a fraction with an imaginary 1 underneath. So this becomes 1 over 2 to the positive third, and 2 times 2 times 2 is 8. So that's 1/8. Moving on, 2 to the -2 would be 1 over 2 to the positive 2, which is 1/4. And the last negative is 2 to the -1, which is 1 over 2 to the positive first, which is 1/2. Now from here, these are either 0 or all positives, which should be pretty quick. You should recall that anything to the 0 is 1, 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. Now remember I said that b was your multiplier and it was 2. You will notice that to go from one y value to the very next one, you would multiply that by 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So it should make sense that we got those numbers. Now you're going to graph these, -3, 1, 2, 3. 1/8 is very close down here to 0. It's obviously don't make it on 0. -2, 1/4. So it's half of half. So half, that's close enough. -1, 1/2 should be a little easier to plot. 0, 1, 2, 1, 2, 3, 4. And then 8 is going to go off the grid by 1, so we can just add it up there. Now when you connect these, make sure you put arrows on the end. And when you do this half down here, you want to make it asymptotic, I don't know how you would say that actually, to the x-axis, because it will never go below 0. You will never get a negative number when you are raising 2 to some power. It will never be negative. Okay, so now we're going to look at the next example. The next example is y equals 1/2 to the x. So this time our multiplier, our b, is 1/2. So that means to go from one y value to the very next one, you would multiply it by 1/2 or divide by 2. So again, I'm going to show you by hand how you would do this. So this is 1/2 to the negative third. When you have a negative exponent, there's two ways to think of it. Way number one is to raise each thing separately to the negative third, and then you would flip-flop. So 2 would move to the top, 1 would move to the bottom. So that's 8/1, which is 8. Or you could just flip-flop the fraction and then make that exponent positive. So it'd be 2/1 to the positive third, which is 8. So either way. So 1/2 to the negative second would be 2/1 to the positive second, which is 4. 1/2 to the negative 1 would be 2/1 to the positive 1, which is 2. And anything to the 0 is 1. 1/2 to the first, so no more negative exponents, is just 1/2. 1/2 to the second, you're squaring everything inside. So 1 squared is 1, 2 squared is 4. And then 1/2 to the third, you're cubing everything inside. So that's 1/8. You will notice these y values are like flip-flopped from the last ones. And you should notice it's because our multiplier 2, its reciprocal is 1/2. You're going to flip 2/1 to be 1/2. So now if you plot these points, negative 3, 1, 2, 3, it's going to be up at 8. It goes off the chart again. Negative 2, 1, 2, 3, 4. Negative 1, 1, 2. 0, 1 again. That one is the same. 1, 1/2. 2, 1/4. And then we're down to 1/8 again. So it should look like the exact same graph, except it was flipped over the y-axis. And then just to talk about the domain and range. So the domain for the, I'll write all of my work over here under each table because you kind of can't tell which one it goes with. So the domain for this one, remember domain is all of your x's that satisfy or work in that particular equation. You can plug in any number for x and you won't get an error. So the domain is negative infinity to infinity. That's your domain. Your range, remember I already talked about this. You will never get a negative or 0. You will never be able to raise 2 to any power and get 0. So the range is from 0 to infinity. It does go on forever up, but it cannot get to 0. So make sure you put a parenthesis, a curved one. And the y-intercept is at 1 for both, actually. The domain and range are actually going to be the same for the other graph, so I guess I could have written them all down here. So the domain, again, goes from negative infinity to infinity. The range also goes from 0 to positive infinity, and the y-intercept is at 1. Okay, so that's it for lesson 4.3. Now on to lesson 4.4. Okay, so 4.4 deals with finding equations of exponentials. So this is where they're going to give you some points, and you'll have to find your A, find your B, and then write your equation. Very similar to finding the equation of a line. So first, let's review. I know you just watched it, but this is the general form of an equation of an exponential function. Again, A, that is your initial value when x is 0. Initial value when x equals 0. What do you get when x equals 0? B is your multiplier. Sometimes you're going to have to find it, and sometimes you will be given it. So you just got to plug it in. So for the first example, they gave us a table. You need to ask yourself, do I know A and can I figure out B? Sometimes it's obvious, sometimes it's not. So I'm going to show you, the first one's kind of easy to do in your head. If you look right here, they gave you the initial value. They gave you what you get when you plug in 0 for x. You get 5. So this is your A. Now, this one's not so bad to figure out. The x's do go up by 1. You got to make sure that you know how much it's being multiplied for every 1. So you can figure out, you can kind of maybe do this in your head. Do you agree that you would multiply every previous number by 3 to get the next one? So your b would be 3. So your equation for the first example would be y equals 5 times 3 to the x. Now, if you could not figure out what it's going up by, because sometimes it's not as easy to just look at and figure out, you would have to pick your favorite point. Pick any point. I'll pick 1 and 15. I know what my initial value is. It's 5. So I know this much so far. Then I would pick a point, 1 and 15, and plug those in and then solve for b. So I'd plug in 15 for y. I'm trying to figure out what b is, so I don't know what b is, and x is 1. So now you're going to get b alone. You would divide, remember, get rid of anything that's added or subtracted first, then multiplied or divided, then exponents last. So you would divide both sides by 5. So that's 3 equals b to the first. Well, you don't need to get rid of a 1, so b is 3, which is what we got anyways. So these are the steps over here that you're going to use when you don't know a or b. Don't know a or b. If you know one of them, you can figure out the other by just using a point. So look at the second example. They actually told you what the output is when the input is 0. So therefore this 8 is your a. So now you know that a is 8. What we don't know is b. And this one is not as easy to just see because they did not give us a table with all of the values, the x values going up by 1. So we're going to have to do what I just told you, where you're then going to plug in this other point. So you have to know that 3 is the x, 1,000 is the y. So you have 1,000 equals 8 times 3 to the x. Oh, I'm so sorry. That's not right. I put 3 in for the wrong spot. We don't know b. 3 is the x, so he goes up there. Okay, again, to solve for b, you're going to get rid of anything that's added or subtracted first, which I don't have anything, then multiplied or divided. So I got to get rid of that 8 first. Move him to the other side. 1,000 divided by 8 is 125 equals b to the third. Then you get rid of your exponent last. So to get rid of a cubed, you cube root both sides. Remember, you got to put the little 3 there. If you don't, it looks like you're square rooting both sides. The cube root of 125, so what times itself 3 times is 125? B turns out to be 5. So now my answer, my final answer, the equation would be y equals 8 times 5 to the x. Don't forget to tell me the actual equation. Don't do all of this beautiful work to then not tell me the equation. Okay, so the last one, this is probably the one you'll see more often than not because they want to actually see you do a little bit more work. And this one you're going to have to follow these steps over here because you do not know what the y value is when x is 0. They did not tell you that initial value. You'll notice they gave you the value when x is 2, it's 36, and when x is 5, it's 121.5. They did not tell you what it was when it's 0. So here's what you're going to do. You are going to take the equation of an exponential function, and you're going to set up 2 systems where you're going to plug these in. This is x, this is y, this is x, this is y. You're going to set up 2 equations with these numbers, and you're going to have 2 unknowns. And then you're going to use elimination or substitution. I'd probably do elimination because something nice will happen. You're going to do elimination, you're going to end up dividing the 2 equations one by the other, and something nice will happen. So let's take the first one. Y is 36, so that's 36 equals, I don't know a or b, so a times b, and 36 is x is 2. Then the other one would be 121.5 equals a times b to the 5th. Now actually I should have done this to begin with, but I'm going to write the bigger number on top because when we divide we're going to end up dividing, not adding or subtracting because there's no plus signs or minus signs. So there's multiplication. So we're going to divide the top by the bottom, and we usually want to divide the top number on, or the bigger number on top. A times, oh my gosh, I'm like just writing the wrong numbers everywhere. This is the fifth. A times B to the second. Okay, so now when we divide, something nice will happen. The A's will cancel out. A divided by A is 1. 121.5 divided by 36 is 3.375. And then if you recall, the rules for dividing with exponents, you subtract if they're the same base, which they're both B's. So B to the fifth divided by B to the second is B to the third. Now I can solve for B because that's all I have left in my equation. I'm going to cube root both sides, put a little 3 there, cube root this side. B turns out to be 1.5. Remember, you can use your calculator for this. It's kind of hard to do in your head. What times itself 3 times is 3.375. Now that you know B, you can take your equation, pick your favorite point. I'm going to pick 2 and 36 to then solve for A. Just because those are smaller numbers, they're both positive, I'm going to pick those. So I'm going to do 36 equals, I don't know A, I now know B, and 36's x was 2. And now I'm going to solve for A. So 1.5 squared is 2.25. And then when you divide that over, A turns out to be 16. So now I can write my equation because now I know A and B. So my final answer would be y equals 16 times 1.5 raised to the x. And that is it. So remember, know your general equation of an exponential function, y equals a times b to the x. And you might have to plug in 2 points and then do division to find, you'll find b first, then plug one of the points in to then find a. And that's it for lesson 4.4.